Good afternoon. Welcome to the today's webinar on Agile testing opportunities on behalf of RBCS and software test professionals. I am Rex Black, president of RBCS. We are a worldwide quality assurance and testing firm. We have clients that range from little bitty startups to big, huge Fortune 20 global enterprises. We've been in business since 1994 as a pioneer and leader in quality hardware and software testing. And we have offices in the United States and partners around the world. We deliver insight and confidence to our clients and help them get quality software and hardware products to market on time and with a measurable return on investment. We do this with a team of international consultants that deliver customized training, consulting, and outsourcing services for companies that are looking to improve their test and quality assurance practices. We've helped literally hundreds of companies around the world reduce their development and support costs and assure that the best quality products are delivered to their customers. I'm the author of a number of books, Pragmatic Software Testing, Advanced Software Testing Volumes 1, 2, and 3, Foundations of Software Testing, Critical Testing Processes, Managing the Testing Process, and Fundamentos de Pruebas de Software, which is the first book on ISTQB certification in Spanish and the first book in any language published that was aligned with the 2011 Foundation syllabus. And I'm also the author of two, maybe even four upcoming ebooks, with two that we know of. One is called Testing Metrics, Measuring Product, Process, and Project Quality. And the other is Improving the Testing Process, a value-based approach to assessing and enhancing testing maturity. I have a degree in computer science and engineering from UCLA, and I'm the past president of the International Software Testing Qualifications Board and the American Software Testing Qualifications Board. We are presenting this webinar in partnership with our friends at Software Test Professionals. If you haven't visited their website, check it out. It's softwaretestpro.com. That's softwaretestpro, all one word, .com. And I will be speaking at their conference in New Orleans next week. So those of you at the STPCon next week, look forward to seeing you there. Now, attendance at today's webinar does earn PMI PDUs. I'd like to thank Michael Lindhorst for reviewing the material. Visit www.pmi.org to claim the PDUs using code AT100. That's PMI PDU code AT100. RBCS's provider ID is 2986. Please note that PDUs are available for live webinar attendance only. RBCS is looking for additional volunteers to review materials for PDUs, by the way. So if you're interested in getting an early preview of these webinars and providing helpful feedback that can improve and beef up the presentations, please send an email to info@rbcs-us.com with the subject line PMI PDU volunteer. Before we start the presentation, a couple housekeeping notes. Have any questions at any point in the webinar, you can submit them via the question interface. Please note that I do not check those questions until the end of the interface, or the end of the presentation, excuse me, because otherwise I would be perpetually distracted and unable to keep on top of the presentation, as I'm just being distracted right now from something happening in the office. Give me just 1 second here. I see that some people were having problems with the audio. Now that it's, I believe though that the audio does seem to be working. So if anybody would like to send me a quick question/chat message, tell me if you're hearing it okay, that would be great. So apologies for the slight technical difficulties that we may be having here. Give me 1 moment to confirm this. Yeah, hearing me fine. Okay, very good, very good. Thank you for all of you for confirming that. Appreciate that. We did have a slight audio setup problem at the very outset, which might have resulted in some of you having some weird sounds at the beginning, but it sounds like everybody's good now. Okay, so with the audio problem out of the way, what else do you need to know? Let's see. Submit the questions as they come up to you. I'll get to them at the end of the webinar. Also, for those of you who are interested in registering for the drawing for free e-learning, you don't need to ask about how to do that. You are already registered just by attending. do check your email over the next few days and make sure that the notification doesn't get lost in your spam filter. Now, getting to the audio or visual components, we just dealt with one of the audio problems, which could be on my end. If you're still not hearing audio, of course you're not hearing this, so I'm unable to troubleshoot that. But one thing that you can do if you have problems with getting to the webinar is to download the slides, which are on the basic library, and then use the telephone to connect rather than voice over IP. And that's an option to deal with that if you have a problem. Most of the time when people have problems getting to the webinar, it's actually a firewall issue, a corporate firewall issue, and you just have to have your security people change the security settings to allow you to download the little applet, Java applet that has to be run, and then use that. So with the preliminaries out of the way here, hope you enjoy this free webinar from RBCS. These are a free service to the software testing community because we are a not just for profit company. So today's presentation is on agile testing opportunities. I'm going to be fast and agile and quick after our prey, like the tiger here. At least that's where we want to go. Now, agile life cycles are becoming very common. A lot of people report using them, having experiences, good and bad, with agile. And this presentation is about helping you recognize ways to have good testing experiences, taking advantage of the opportunities that are created by agile if you're in an agile world. Now, I gave a presentation some time ago about agile testing challenges. I've given that presentation a few times, and certainly part of what you want to do is deal with those challenges. I'm not going to spend time on the challenges today, but you can go and catch the recorded webinar, which is in our digital library. So part of what you have to do to be successful in testing in an agile world is one, deal with the challenges, but you also have to take advantage of the opportunities. So today's discussion is focused on those opportunities. So let's take a look at what these opportunities are and how testing can benefit from them and take advantage of them. So the first one, perhaps the most obvious, is the plethora of tools that are available for automated unit testing frameworks. So there's commercial tools like CPP unit, or the C++ unit, excuse me, which is the Parasoft tool, and then there's open source tools like JUnit and NUnit and so forth. There's a variety of those tools out there, quite successful in the marketplace, quite widely adopted, and especially adopted by people in the agile world. So developers who have truly bought into the whole agile concept, whole process of doing agile, being agile, will often have also bought into the idea of creating automated unit tests as part of their development of their software. Now, it's important to be realistic about this. Unit testing is not going to save the world. Unit testing is not the answer to the quality issues that plague software by itself. And the reason for this is that the defect detection effectiveness of unit tests does tend to be rather limited. Data is a little bit spotty on this, but Capers-Jones's studies seem to indicate that at the low end, low quality, low coverage unit tests will tend to have only about 10%, to detect only about 10% of defects. When I say coverage here, I'm talking code coverage, because we're talking about code-based unit testing here primarily. You get up to the high end of defect detection effectiveness, according to his studies, looks like it tops out at about 50%. And just to put that in context, what we found is that highly effective independent system test organizations, system test, system integration test, late level testing, end stage testing, if you will, those can have a defect detection effectiveness as high as 95% or above, so roughly twice what the most effective unit tests can be. But still, it's certainly nothing to sneeze at to say we remove half of the bugs before the code is even checked into the code base, into the repository. That's really good. I mean, if anybody in their right mind, when asked, would you like half of the bugs to be removed before the programmer checks in the code, is going to say, yes, let's do that. So let's do that. Let's help our development colleagues in that regard, support them in that regard anyway, at least. Now, these automated unit tests are useful not only in the process of getting the code whipped into shape when it's being initially checked in, but also very useful from a regression risk management point of view. They might say, well, how does that work? Well, what you do is you create a framework that is integrated into the build process, and more about that in a minute, that causes these automated unit tests to be run every time the code is changed, or maybe if that's too frequently, every 4 hours, or overnight. I've seen different variations on this frequency of execution of the unit tests, but the idea is that the automated unit tests are checked in with the code, and then when at some regular interval, as I said, which could be as frequent as every time new code is checked in, to as rare as overnight, once a night, which ain't so rare. When those tests run, if anybody checked in anything else that caused some of the existing units to stop working, now voila, the defects will be detected by that. Now again, it's not an absolute barrier. It's certainly a relatively porous barrier in many ways to defects. When I say relatively, I mean relative to some other forms of regression testing. But again, why poke it in the eye with a sharp stick, as the saying goes? It's going to help you manage your regression risks, limit the number of regression defects that sneak in to later stages of testing, and really, anything is good, right? I mean, when you're talking about early defect detection and removal, you'll take all of that you can get if you're wise. Now, this framework not only would run the automated unit tests, but also there are static code analysis tools and code coverage tools that can be combined into this automated framework, and I'll get into that more later. But we've seen another number of clients that have put in place these the big integrated unit testing and static analysis code coverage frameworks, and they're very, very happy with the results that they're getting from that. So definitely recommend that for all listening. Now, just a historical note. This, by the way, is while this concept has been popularized with Agile, it is indeed a concept that has been around for quite some time. I mean, I remember building automated unit tests back in the late 1980s and early 1990s, and putting those into frameworks. Now, of course, at that point, we had to build our own frameworks, and we had automated unit tests that ran overnight when I was a test manager back in the early 1990s. So these concepts are around sometime. They're not new, but that's actually good news, because that means that they are proven best practices that have stood the test of time. Excuse me. Okay, so on to static code analysis. So the idea of static code analysis is to basically have a tool read through the code, parse the code like a compiler, but instead of compiling the code, to actually look for problematic structures in the code, problematic coding practices of various sorts. Now, For those of you who are not familiar with the concept of what code analysis and static testing in general are, there's a recorded webinar on the digital library of the website. So feel free to go and take a listen to that to get more details. But in a nutshell, basically what these things are doing is that they're, as I said, parsing the code just like a compiler, figuring out what it says, and then looking for patterns, or if you prefer anti-patterns, in the code that match up with known problematic patterns that it knows how to look for. Now, this is more sophisticated than what a compiler does. A compiler just looks for can legitimate executable machine language be translated out of the source code, right? So as long as you've got the program is legal, basically all the statements are well formed and everything that you're doing conforms to the requirements of the language, the compiler will produce an executable version of that. But the static code analysis is looking for things like you declared a variable and you never used it, or you allocated some space and you never deallocated it, or you have a variable name that is too short, and you've got uncommented code or uncommented blocks of code. So there's a variety of things that they know how to look for. Some of them are also can be specialized in, depending on the tool that you get, looking for security issues like copying from a buffer without checking the length of the target memory that you're copying into. So doing a straight string copy rather than a string copy of a limited length. So these things can find all sorts of issues, and some of those, like the security problems and the maintainability problems, are things that dynamic testing by executing the code, really can't find very easily. It's not going to be very easy to find some of these security and maintainability problems with a dynamic test, but static analysis tools can do a fine job of finding them. Now, as I said, these tools are widely available. There are both freeware and commercial tools for this. Both freeware and commercial tools are quite accepted. So, whichever path you go, you'll be able to find a tool that you'll like, a tool that will work. Now, of course, like anything else, tools have to be carefully evaluated. You can't just you can't just go and download the first free tool you find on the internet and expect to be happy with that. You have to go through an evaluation process, but certainly if you go through a careful evaluation process, then you can get good tools here. Now, as I was mentioning before, these static analysis tools can be, and I believe should be, integrated into your larger automated build framework, and again, more on that in a minute, so that not only do the automated unit tests run regularly, but the static code analysis is run regularly as well to make sure that the quality of the code is maintained. Now, we've had some clients that say, well, really only needs to be done when the code is new or changed, so we don't want to integrate it in. We don't want that extra overhead there. As long as you have, as part of your check-in process, or as part of your code review process as a prerequisite to check in, making sure that people do run the static code analysis, that can be fine. Now, there's some caveats about static code analysis that I'm not going to get into here related to how it deals with a legacy code base, if you will, a large established base of code, and should you try to run the analysis against that and fix all of the problems. And the short answer is no. For a longer discussion of that, I'd refer you to the recorded webinar that I discussed that talks about static testing in general in much more detail. Now, on to code coverage. Again, this is another topic that we could spend an entire hour going over, or hour and a half, and indeed I have done that. There is a again, another recorded webinar out on the website, the digital library page of the website that discusses how code coverage tools work and how to interpret what they're telling you. So if you're in a world where code coverage is being used, or if you want to get it to be used, which I think you should, I'd encourage you to go take a listen to that webinar, take a look and a listen to that webinar, and get more up to speed on what exactly the tools mean. It's one of the potential problems with these is that some of the people that are currently using code coverage are not actually clear on what it's telling them. So they look at these percentages and percentages of coverage achieved, and then so you ask, well, is that good or bad? And they don't know. They don't know how to interpret those coverage numbers. So I think it is important that people be educated before they use tools about what the tools actually can and can't do for them and what the tools are and are not telling them. Now, in the short version of this is that the code coverage tools, when used by a developer, will tell that developer from their unit testing what has been tested and what hasn't been tested. And presumably then you would have a rule, an exit criteria of some sort, if you will, that says that unit testing should achieve X percentage of statement coverage and Y percentage of decision coverage, etc. Personally, I think that statement coverage and decision coverage should both be at 100%. It's kind of hard to imagine why you would want to have untested code or untested branches in your code being checked into the repository. And it's, I don't think, terribly difficult to set that standard. Now, the code coverage, when it's used on unit testing, and you hold two standards like that 100% of statement and decision coverage standard, will tend to push the defect detection effectiveness of the unit testing up into that 50% range that I mentioned before. So it's an aid in maximizing the effectiveness of your unit tests. And again, this can be incorporated into the regular hourly or nightly, what have you, automated tests that get run. Other organizations say, well, no, the probe effect is too high. In other words, the intrusiveness of the code coverage measure is too high. So we only measure the code coverage when we're checking in new or changed code to make sure that we've hit our exit criteria. But with the automated unit test runs against an uninstrumented version of the code, and that's fine too. I mean, I think that's perfectly legitimate. The only thing that you miss from that is a comprehensive report across all of the code about what percentage of statements and branches have been covered across the entire code base. Now, if everybody can prove that for every single unit that's been checked in that the 100% statement and branch coverage has been achieved, then certainly 100% statement and branch coverage has been achieved across all of the code. But management visibility into that might not be as good. So you have to sort of consider these things, the pros and the cons of, what are you going to do with that code coverage metric? Is it a purely tactical metric for the developer, or is it a sort of a project management metric that people are looking at in the project management team? Now, there are a lot of different tools, both open source and commercial, available to help with this. So again, just careful selection is the key here. You don't have to have a lot of money, but you definitely do have to have time to succeed with and this is true of any sort of testing or development tool that most people think that the magic ingredient is a ton of money, but usually, in my experience as a consultant and as a practitioner, that I found that the thing that really makes the difference is investing the time to make a smart selection decision about the tool, and then investing the time to pilot the tool, and investing the time to launch the tool successfully. Those are really the much more key, I think, than having an unlimited budget, and that's certainly the case with the open source tools. Now, one other thing I'd like to mention about code coverage before we move on. Some people say, well, can code coverage be used for me as a test manager or a professional tester to measure how thoroughly our tests test the code? And sure, it absolutely can. I think that's a good practice to periodically, especially if you've got a set of automated regression tests, to run your automated regression tests, or just your larger set of tests against an instrumented version of the code. Instrumented meaning having the code coverage analysis turned on, built in, and then look at what you're testing and what you're not testing. What I would encourage you not to do is to set an arbitrary code coverage target for system testing or system integration testing or acceptance testing. That's that. You know, the line about the management cliche, if you will, about what gets measured gets done comes into play here, and then its corollary is, of course, what doesn't get measured doesn't get done. And so the problem with having these arbitrary code coverage metrics for system test and system integration test is that you might end up distracting yourself, spending a lot of time chasing down code coverage, when really at system test and system integration test levels, you're much more interested in things like requirements coverage and risk coverage and configuration coverage and use case coverage. And in the Agile world, you know, maybe you're talking about user story coverage. You know, there are other dimensions of coverage that I think are a lot more important at those upper levels of testing. And so finding out what your tests cover and what they don't cover periodically, and evaluating what you don't cover to see if maybe you should add some tests, and maybe evaluating what you do cover to see if maybe you're over testing certain areas is a good exercise. But I would say, you know, do that periodically. Your overall coverage metrics for system test or system integration test, which are very important, should really be focused on more of the black box type of metrics, like, as I say, risks, requirements, user stories, configurations, etc. Now, I've been talking about this idea of a build framework, and that brings us to another good practice that a lot of people in the Agile world have embraced, along with the automated unit testing, static analysis, and code coverage, is this idea of continuous integration. So constantly checking code in to a, maybe not the mainstream, though some of our clients do that, but certainly into a branch of code that everybody else in the sprint team is checking their code into. And this allows you to surface kind of any sort of integration, major integration issues, the quote-unquote broke the build type of issues, immediately. Rather than you know, the old bad practice of integrating like once a week, or even less frequently than that, and then, you know, people try to check in their code, and oh my God, you know, the build is broke, and who broke the build, and there's all sorts of work associated with fixing that, and it's more work than it would otherwise be, because by the time you get around to fixing all those integration issues, people have kind of gotten stale on what they were working on before, because they're working on something else. So there's a reinvention of the wheel problem that comes up there. People go back and try to figure out what they were doing. So continuous integration certainly leads to a significant reduction in terms of broken builds, and sometimes even eliminates it. And it definitely goes a long way to dealing with that bugbear that gets under the professional tester's skin so often, which is that untestable build delivered for testing problem, which any of you who've been in testing long enough have had that experience. Now, the idea here is that the continuous integration process is automated, and the automated unit tests are static static code analysis and the code coverage are hooked up into that, or maybe not. As I discussed before, it's not always a repeated part of what gets executed on code check-in. Sometimes it's just a one-off, but certainly the automated unit tests can get combined into the continuous integration framework. Now, the best practice is also to say, well, we're going to look at building some tests that specifically check component integration. So they're specifically looking at do the components talk to each other properly. Now this allows your continuous integration framework to serve as a form of automated component integration testing, including regression testing of the component integration, which is very helpful because that's something that doesn't happen anywhere near as often as it should. And you keep in mind that just because the build isn't quote unquote broken, in other words, a broken build means that you literally can't compile an executable. It doesn't mean that the build is not broken in some sense of two components that used to talk to each other now don't talk to each other because of a modification made in one or the other of the components. Those two components can still pass their unit test just fine, but if there is a change in terms of how they interact with the outside world, that change could impact another component. So your automated component integration test can catch that. And better yet, you can build on top of this an overall what's sometimes called a build sanity test or a smoke test that goes through and checks end to end. Basically, it's kind of like a component integration test, except that instead of just testing the way that two components talk to each other, you're testing a whole collection of components that actually integrates or implement some sort of major function. And then those components or those components together either successfully implement the function or they don't. Now, if they don't, then you fail the sanity test and it's not ready for larger scale testing. And this also can reduce the chances of the test team receiving what is ultimately an untestable or barely worth testing kind of build. Now, I'm sure I'm starting to sound like a broken record here, but once again, there are many tools available to support continuous integration, and those do include open source tools. So, again, the magic ingredient here is not money; it's time. Spend the time to pick out good tools, and you will be happy. For example, a number of our clients are very happy with the Jenkins tool, which is the successor to Hudson, and so we do know a number of clients that are very successful in using that, and very happy with the way that it works. Okay, now you might be saying, all right, Rex, so that's great. So far, you've been talking about stuff that really helps the developers build better code, which is good. What can I do about that as a tester? Well, of course, as I said, support and encourage. And maybe if you've got the technical capability within your test team, take on a more active role in promulgating and supporting that. Become kind of a not just an advocate, but also a technical support, if you will, to help ensure consistency and implementation of these agile best practices throughout the development world, at least your development world. Now, there's not just stuff for the programmers in the Agile universe. There are also automated functional testing tools that are out there, both commercial and open source, as before. So one example is a tool called Fitness, which is used to create what are sometimes referred to as acceptance tests. Now, I think that this is kind of a dangerous use of that phrase. Acceptance test really is kind of an overloaded phrase in testing already because it refers to a lot of different things, and also different words are used to refer to the same thing too. So, in the IT world, developing software for internal use, you hear people talk about user acceptance test. And in the mass market, enterprise software world, you hear people talk about beta test. They're really pretty much the same thing, with the exception that sometimes people want their beta test to find bugs. Though it's also true of user acceptance tests too sometimes. So a beta test or a user acceptance test would be a test that's run at the very end before something is put into production. Usually what we find when people are doing quote-unquote acceptance testing is something that could probably more correctly be called a feature verification test. Now, the reason I call it a feature verification test is that conceptually, you think of verification and validation. Verification is about checking whether we're compliant, the system is compliant with the specifications. Basically, it meets requirements. And these fitness tests can really be thought of as a form of executable specification in many ways. Now, the unit tests too, JUnit, for example, those are kind of an executable specification as well in a lot of ways. It's more of a detailed design specification, whereas fitness is more about, at the user story level, what do we want this particular feature to do. But I think if you think of it as a feature verification test, then that's that's a good kind of mental translation. Even if people within your organization insist on calling them acceptance tests for whatever reason, smile and nod and think feature verification test, and that's probably a better way of mentally thinking about it. But call it what you want, whatever anybody wants to call it. These things are very useful. And this is where, with things like fitness, you can start to get involved in actually helping to build these feature verification tests. And there's also open source tools available at the UI level, like Selenium. Now, that's focused on web interfaces, but there's other stuff that's out there that can help with interfacing, or automating at the UI level in a non-web world. Now, there's there are challenges here, because we've once again sort of re-entered the browser wars, which had sort of subsided in the 90s and early 2000s. Well, now we're back with people using a lot of different browsers, and you've got compatibility issues and so forth, which does definitely tend to make testing through the graphical user interface challenging, even in a web world. And then you get the additional challenge of people have mobile apps, and they've got pad computer apps, and they've got Windows apps maybe, and how do they all work the same, or how to test them. There's a number of challenges there, but at least the tool sets are sort of keeping up, if you will, and evolving to help us with this. Now, excuse me. Can you take these automated functional tests and integrate them into your larger continuous integration frameworks and have this stuff all run automatically? Yep, you can. We've seen clients do that. And it's, again, very, very helpful to have these kinds of filters in place, if you will, that are automatically detecting certain kinds of bugs, especially regression bugs. So would encourage you to think about the new opportunities available. If you're not doing automated functional testing, the new opportunities available for automated functional testing that are associated with agile worlds, and don't think about those in isolation. So if your development colleagues are off beavering away with Jenkins and JUnit and Clockwork and whatever coverage tool they're using, don't say, okay, well, that's their world, and now over here in my world we're going to do the automated functional testing. That's not agile, as the saying goes. I mean, the idea in agile teams is that people work collaboratively to exploit synergies and be more effective. So work with your development peers to say, hey, here's this other cool piece of the puzzle that we have available to us for automated functional testing. We want to put that in place. How do we fit that into what you're doing, and how do we make sure that we're instead of having gaps and overlap, that we've got this nicely aligned thing that we're doing that fits in well together and integrates with your tools and so forth. Now, here's something else for us as testers that is a good benefit, a good opportunity that comes out of Agile. So, in Agile, you often hear this phrase, user story. Though some of our clients that are doing Agile or Agile-like development still talk about requirement specifications or use cases. Again, whatever they're called, they're descriptions of what the software is supposed to do, right? And in Agile best practices, those will go through a review by both business and technical stakeholders very early on in the sprint. Sometimes this is referred to as scrubbing or cleaning up the user stories. The idea is to get them well defined before the coding work starts. And of course, this is again a well-established best practice of don't start building anything until you understand what you're trying to build, right? Now, in a Agile best practice type of situation where their implementation of Agile is done really well, the testers that are in the sprint team will also be involved in those reviews. And they not only are they learning about what they're going to have to test, but they could also contribute to the cleanup of the requirements. So we get higher quality requirements, which is always good, regardless of the life cycle you're in, whether it's a sequential life cycle model like a V model, or it's a iterative life cycle model like rational unified process or rapid application development, or it's Agile like Scrum. And we also get a better test oracle. Test oracle meaning the thing you refer to determine whether your tests have passed or failed. And you're there at the creation, as the saying goes. You're there seeing it put together. And if there are any sort of problems, testability problems with the requirements, you can bring them up in the reviews. So we have defects being removed early, which is always good, and also defects being prevented in the sense that by focusing on testability and really understanding what the software is supposed to do, we can prevent defects from subsequently being introduced into the code. So another nice opportunity from Agile. Now, this is a two-way street, and this is cool too, because in sequential lifecycle situations, one of the things that we see with some of our clients is, well, we create tests and we want to get stakeholder input on the tests, but everybody's too busy, so we don't know. And then we run the tests and we come back and we report bugs, and somebody says, oh no, that's not actually a bug, it's supposed to work that way, and there's all sorts of false positives that happen. And this is something we hear from a number of clients. In Agile done properly, that kind of scenario should not happen, because not only are you there in the requirements reviews, you, the testers, there in the requirements reviews, seeing what's happening with the requirements as they're developed and contributing to that process, but also there will be reviews of the test conditions. Now, these test conditions are sometimes referred to as acceptance criteria in an Agile world. Again, call them what you want, but the test conditions are, what's to be tested, right? And so you get that feedback on, you say, oh, this is what I think the acceptance criteria ought to be. This is what I'm going to test, and the business and technical stakeholders would say, yeah, that makes sense. It should do that, and it shouldn't do that. So that's correct. Or they might say, well, yeah, some of this is right, but what you're saying it shouldn't do here, actually, it's allowed to do that. So that if it does that, that's not a bug, that's a feature. And so your number of false positives are going to go down, because you're not going to be reporting as many quote-unquote bugs that are actually just intended behaviors that weren't maybe 100% clear from the requirements. Your number of false negatives will also go down too. Now, by false negatives, I mean bugs that you missed that you really could have caught given the scope of your testing. And The reason that'll go down is that you're going to have people involved in those reviews that are going to look at the tests and say sometimes, hey, how come you're not testing X? I think you should be testing X. It's not in here. Can you add that? And now you've got an additional condition that's going to be covered, and sure enough, you might very well find a bug that you would otherwise have missed. So this really helps with improving the quality, the effectiveness of testing, the efficiency of testing. You're focusing in the right place. Meaningfulness of your results is improved from this, because when you say pass or when you say fail, everybody's sort of on the same page as to what it means for a particular feature to pass or fail a test. Our level of confidence is going to go up collectively as a sprint team and as indeed an application team, because everybody understands what the tests mean, and when the tests are passing, you can say, yes, we know what that means. Our confidence is high. And the insight also goes up too, in the sense that people understand what's being tested and how much, it addresses one of the problems that we've seen with a number of our clients, which is lots of data coming out of the test group, but people don't tend to understand what it means. I recently was quoted in an article, I think it's Search Quality Software, I think was the name of it. It's out on my Facebook and Twitter pages. I think a couple days ago I posted a link to that, so if you want to read further about problems that can exist when people don't understand the meaning of the test results. This really is, it's a bigger win than it might on first blush appear to be. It actually is quite significant to just have people paying attention to what's being tested. Now, here's another opportunity potentially coming from Agile. It's the reasonable workload, the sustainable pace is one of the Agile principles. Now, it's hard for people to change their style overnight, and this includes managers. There's a well-established culture, especially in startup companies, of just driving people hard, burning the candle at both ends. We've certainly seen that in other companies too, even in organizations that are in very fast-paced industries like finance. We've seen sort of a tendency that even once they go Agile, they're still doing things that aren't so great, like forcing all of the testing to be done on a particular sprint's content. And so what happens is, if too much content is built on Sunday night, and the Sunday night at the end of the 2-week or 4-week sprint, the testers are regularly always going to be in the office or working from home running tests to try to meet this sort of arbitrary deadline. It really isn't supposed to happen. What's supposed to happen is that if you bite off more than you can chew, you're supposed to push some of that out to the subsequent sprint. And chew means test, not just develop in a proper Agile implementation. So this doesn't always happen, but let's say it does happen. Let's say that we're going to try to keep to that. Well, one of the things that would happen is that there would be good estimation. There's a tendency to use in Agile teams something that's called planning poker, which is kind of a gamified version of the wideband Delphi estimation technique, where you get the participants together to try to estimate how long something is going to take, and then based on a known what's called a burn rate, the speed or velocity is the term you sometimes hear, with which a certain number of story points can be gone through, how much fits into a given sprint. And so testing needs to be involved in that. Testing needs to be part of the estimate. The proper measurement of these burn down charts has to be done, and there has to be a process of triage that eliminates functionality from a sprint if indeed it cannot be built and tested within a standard sustainable pace type of week. What gets held out by the Agile purists is the 40-hour work week, and that's great for those who get to have it. And certainly, I think that should be a good standard to aim for. Given that I tend to work anywhere from 50 to 70 hours a week, I have a hard time imagining what I would do with my free time in a 40-hour work week. But many people do have lives, and it would be good for the workload to not burn out the testers. Now, I want to mention something here because I gave a presentation of this, a live presentation of this material, and got a question on this bullet, second bullet here, the testing tasks that are outside of the sprint, such as test automation. Here's what I mean by that. In some cases, it's necessary to do things like build testing frameworks and create large repositories of test data and do other kinds of things that are of benefit not to a particular single sprint or even single sprint team, but actually are benefits across a number of sprint teams. They're testing tools or testing resources that will be used across those teams. And we've seen in this case the situation with a few of our clients. So what you don't want to do in this situation is tell a tester working inside a sprint team, hey, in your free time, work on X, because there isn't going to be any free time. At least that's the theory is that the tester is to be doing a sustainable work pace, and via the estimation, you're trying to figure out exactly how much work can be done within that. So the estimation process is working properly. Everybody within the different sprint teams is exactly 100% utilized. They're not 95% utilized. They're not 90% utilized. They're not 110% utilized. They're exactly 100% utilized. So no one has any free time. So if you have any sort of long-term project that needs to be done with respect to automation or test data or test environments, those sort of things, you cannot assign those things to somebody inside the sprint teams because it just won't happen, because the scrum master or sprint leader or team leader, whatever the person's title is, their job is to focus their resources in the sense of the sprint team's resources on the immediate priorities, the user stories for that sprint. So if they became aware that some tester was carving out time to do something that wasn't of immediate interest to the sprint, then they wouldn't be too happy about that, because that's not supposed to happen. So it's important that if there are these kinds of longer range types of projects that need to happen, that those be done by people outside of the sprint team. So this is something I think is important to recognize, is that Agile does not mean no more testing teams and we just have individual testers embedded within sprint teams, because if you do that, then any sort of long-term testing priorities will just simply cannot happen. Now here's another Agile testing opportunity that's very nice for us as testers. It's not something we necessarily have a lot of control over, but again, it's something that we should support. Now, what we hear from our clients that have the best implementations of Agile is that they have what's called a fix bugs first approach. And what that means is that if there's any circumstance in which there is a bug that's discovered in a sprint and cannot be fixed in that same sprint or iteration, that the first thing that's done in the subsequent iteration is to fix that bug. And basically what this means is that your bug backlog can never be more than the total number of bugs discovered in any given iteration. And notice that's worst case. That's like if every bug we found in an iteration wasn't fixed, then okay, we'd have that many bugs. So the maximum number of bugs would be discovered in 2 weeks. It also means that the closure period is going to be short. By closure period, that's the average time from open to close of the bugs. So if you look at your closure periods on traditional sequential lifecycle models, you can see these enormous closure periods, days, not just days, but was sometimes weeks, months. And this is really problematic when you have bugs that have languished for months. So if you've got this kind of fix bugs first approach, and the worst case is that your backlog every now and then gets up to again, whatever the number of bugs that tend to leak out. Let's say it's 10 or 20% of the bugs found in a sprint, and then that would be worst case. Still, those are going to get choked off at the beginning of the next sprint. So, if you got 2-week sprints, assuming that the bugs are found more or less evenly across the sprints, then your closure period is going to be about 7 days. And again, that's kind of a worst case. So, that's quite good if you can get into that situation. Your technical debt load is pretty low. Now, we also see that, time to time, there's technical debt that accumulates from a design perspective rather than from a bugginess perspective. So our clients that are doing Agile really well also have periodic stabilization sprints that they do. And this is something that we can help with in testing by getting some good metrics on our bugs, on bug backlogs and closure periods, and complexity metrics on the code and so forth. So it is something we can support. Now, all of these things have sort of a common theme, which may or may not have jumped out at you yet, but I'm going to try to tie it together here with a bow, as we say. A lot of these things, as you were listening, you might have realized, man, that's some pretty technical stuff. That involves a real good technical understanding of things like the programming language that's being used and the programming environments, the integrated development environments that are being used and so forth, and that is definitely true. So the testers who are best positioned to succeed in an Agile world and to take advantage of these opportunities and deal with the challenges that I mentioned in my other presentation are the most technical of the testers. So there's a lot of, I discussed a lot of things that had to do with automation of various kinds of tests. Again, experience with test automation is very important in these worlds. So, if you're a test manager and you're building a team in an Agile world and you're kind of thinking, well, what do I need here? Well, what you need are technical people and automation people. So definitely kind of rework your skills profile, if you will, for your test team, and try to increase the level of technical skills and automation. Now, you might say, well, can't really do that. The team is what it is. Well, in that case, you have to use things like training and cross-training and job assignment opportunities and so forth to try to instill technical capabilities within your teams. But, one of the things that we do hear from developers and other technical stakeholders in Agile situations where we go in and do assessments, we do hear complaints from those technical stakeholders if the testers aren't quote-unquote technical enough. And you can kind of rail against that being unfair and what have you, but it sort of is what it is. The expectation is that you're going to bring a certain level of technical proficiency to the game, as it were, and it's something that you would need to increase. So as a test manager, be aware of that. Okay, so hopefully at this point you're aware of a number of interesting and useful opportunities that are presented in an Agile world, and certainly you're also, I hope, aware of ways to embrace those opportunities, whether through supporting other people's work in the development areas, for example, or actually getting involved and carrying part of this load. As I said, a lot of these things a lot of these opportunities that are really going to be available most when you and your testers have the right level of skill, so and the right kinds of skills. So make sure that you're focused on that. Overall, I think it's fair to say that if the challenges that I mentioned in my other presentation are managed, and if the opportunities that I've mentioned in this presentation are exploited, we should tend to see increased levels of software quality compared to a traditional approach. Now, I'm still waiting to see data on this. Of a lot of people say, well, agile development leads to better software. I think it's possible that it can. Again, if the challenges are managed and if the opportunities are exploited. It'll be interesting to see if over the next decade or so we actually get some data that shows that it has. So, if anybody's aware of any sort of studies, and I'd say ask for unbiased studies on this that show that that increase, definitely please forward that on to me, because I'm always on the lookout for data. Okay, so that's the end of the presentation proper. So let's go ahead and get the undock the question interface here and see what we got question-wise. I will, as usual, start at the top here, and let's see. There's a question here about will this webinar be available on your site at a later stage? Yes, it will be recorded and posted on the digital library. The slides are available now on the basic library, so if you scroll to the bottom of the basic library, you'll find the current slides, and in about, it's usually less than a week, the recorded webinar will be posted, and you can actually direct people at it, direct people to it, have them watch it. Let's see. Somebody asked, please repeat the PMI provider code and activity code. Okay, we'll do that. The PMI provider ID is 2986. That's for RBCS. And the PDU code is AT100 for those of you who are looking for that. Let's see. I had a number of people confirming that the audio is working fine. Thank you all for that, helping me out with that. I'm not sure exactly what happened. It was an interesting little glitch. Let's see. Peter asks, can I get credit for attending this webinar so I can apply the credits towards my ASQ CSQE recertification? I don't know. We can certainly attest to the fact that you attended. You're going to get an email that's going to confirm that you did attend, Peter. So you might try forwarding that email on to them. And that's certainly something that that's worth trying. Let us know how that works out when you give that a try. Okay, Peter? Erica asks, have you done Agile with offshore teams? Well, we have some clients that are kind of experimenting with that, Agile in distributed spaces. It's challenging, without a doubt. It's challenging. I mean, it depends on what you're using the testers to do. Okay, so let's say that that we have a model where we have a tester working within the sprint or scrum or whatever, agile team, whatever you want to call it. That person is embedded in there. It's going to be very difficult for them to participate in some of these things if they're separated by a lot of time zones, because there's a lot of focus on collaboration and face-to-face conversation in an agile world, and you can collaborate, and with telepresence you can have face-to-face conversations when you're not in the same place. You have to work at it to make it work, but it's the time zones that really get to be problematic, because if people are not in the office, they're not working at the same periods of time, you start having uncomfortable things like people having to come to the office really early or stay really late, and usually it's not everybody doing that, but just somebody whose job is to coordinate, and then you have the problem of messages getting mangled in the translation and so forth. So it's definitely a challenge in that situation. Now, let's say that you've got 10 agile teams. They're working in each building some part of a program. Let's say an application, right? So we have an application that's being built, and there are 10 different chunks of it that are in progress, and those are being built by different sprint teams, and then periodically the sprint team, let's say every 2 weeks at the end of each sprint, delivers software into a larger integrated code line that includes all the code from all 10 of those sprint teams, and then that code goes through a system integration test. Well, in that situation, certainly we can use an offshore team to do the testing there. That the geographical and time zone separation might be somewhat less of an issue, because we would expect that that team is not necessarily embedded within the sprints. So that's certainly something that we've seen work. Let's see. Julie asks, are these slides going to be emailed to us? No, they are not emailed. They are posted on the basic library. As I said, they're right at the bottom, so you can go there and easily find them and download them. But no, we will not. We do not email out materials. They're available on our website. And so Stefan asks, can a development team and a QA team share the same continuous integration framework? The first running test at unit component level, the second running test at a functional level. If yes, what are the risks? What are the precautions to be taken? So yeah, the short answer is yes. Now, certainly there are risks. One is just that the amount of testing work that is being done by the framework becomes large enough that, given the hardware available, CPU cycles, memory, etc., it takes too long to run the tests. Now, too long is, I understand, a very squishy term, but too long is a different thing for different organizations, right? See, some places want to be able to run these tests like every 4 hours, as one of our clients did. So something that made the tests collectively last longer than, say, 3.5 hours would be a problem, because you'd start to run into risk of bumping up against the next test run, right? If you're happy to have the tests run overnight, then, assuming they kick off, say, at 8 o'clock, when the last developer has left the building, and you want them done by, say, 9 a.m. As the testers and developers start coming in, then you've got 12, 13 hours in there. But you got to think about the timing, because we have seen clients have problems with that. Excuse me. It's also necessary that the tests be very well aligned, one to the other. These groups of tests. So you want to make sure that people understand what's being covered by each of those sets of tests and what they're actually telling us, because otherwise you can have some confusion comes out of this. The other thing that's really important in these situations is don't use collective test counts. Test case counts just in general are really, really bad and questionable metric when aggregated. Sometimes they're even bad just within individual groups, because the granularity of tests can be different. But definitely when you're comparing, say, a JUnit test to a fitness test to a Selenium or Quick Test Pro test, the granularity, the scope of coverage of those tests, of what constitutes a test case in each one of those situations, is so much different than to say, add up test case counts across those 3 different types of tests and say, oh, well, we ran 26,272 tests last night, and of those 93% passed. That is just a completely meaningless metric. That would be like taking temperature readings in Kelvin, Fahrenheit, and centigrade and coming up with an average out of those. It's just don't do it. That's one of the big risks. I hope that addressed the question. That was a great question. Thank you for that. Let's see. So I got a comment/question from Andre. He says, hi, Rex. In my practice, I face customers which are too lazy to review requirements and acceptance criteria too sometimes. It's really bad for our business because we have to do too much rework due to unreviewed and unclearly defined requirements. We provide them our vision of requirements and prototypes, but they don't want to review requirements and prototypes carefully. Do you have the best idea, in capitals, how to describe customers, they are our stakeholders, that performing such activities can make their work with our product easy easier in both short and long-term perspectives? Okay, that is a great question. So there's a number of different answers to this, right? So for one thing, notice that I've been saying throughout this presentation that there's like companies that do Agile right, and then there's companies that are doing what they're calling Agile, but it's kind of not really. I haven't come out and explicitly said that, but that's now I have. What you are describing, Andre, is exactly that situation of companies are doing things that they're calling Agile, but they're leaving out some of the practices in Agile that actually make Agile work. If you want to be able to deliver running software every 2 weeks or every 4 weeks, then that's based on this concept of business stakeholder involvement throughout the process. And if you pull that out, then you get these unhappy surprises at the end of each sprint where the customers coming in or users coming in going, no, that's not what I wanted. You didn't understand. Yeah, okay, well, I built what you told me you wanted, and that could have been 20 different things. This is one of them, right? So, I think you need to have that conversation with them, is that, in order for us to be agile, in order for us to be fast and efficient, presumably the customer wants, the stakeholders have to do this, right? So you want X, you have to pay me Y kind of conversation. The other thing that's probably worth doing too is really focusing on the pain that's created by these situations. You start to quantify some of the time that gets burned on both sides of the relationship by these kinds of that's not what I wanted. You built X and I wanted Y, and start to explain to people the consequences of not reviewing the requirements, not reviewing the acceptance criteria are this many person hours or this many dollars or euros or whatever of waste per month. Because one of the rules of process change, sales in general really, is that people tend to move away from pain a lot faster than they move towards a desired situation. So you can talk about things that people say they want, and that's motivational to a certain extent, but if you talk about things that are painful, and money loss is always painful, then that does tend to be motivating. So Peter asked an interesting question here. What is your definition of technical debt? So Peter, I'll admit to being somewhat sloppy here in that I'm not going to be able to whip out for you a formula and say, I would calculate technical debt as X. Now, if you're looking for something like that, by the way, Capers-Jones's most recent book, Economics of Software Quality, has a pretty nifty little way of calculating the economic cost of technical debt, actually expressing it in terms of currency. I forget exactly how it works, but I remember reading it and going, that's pretty slick. It's if I needed to put a dollar figure on it, if I needed to actually calculate it, quantify it, I'd try that. But qualitatively, when I'm talking about technical debt, part of it is the number of bugs that are known to be in the product, but are not fixed, right? So the larger that number, the larger the technical debt. And I would say that also has to be compounded in some way by the closure period, the one I was talking about before, the turnaround time associated with a bug. For each bug, the longer it has been latent in the system, latent in this case I mean known and yet still there, the higher the level of technical debt associated with it, in my opinion. Now, another thing that I would plug into this whole idea of technical debt is complexity. So complexity, you can talk about, there are a number of different metrics for it. Sort of the old standby that's been around a long time, and a lot of people have thrown rocks at it, but it's still used, and indeed free tools are available for this to measure it if you're interested. It's McCabe's cyclomatic complexity metric, which, it got kind of mystified and confused by it's all based on graph theory and you're counting up edges and nodes and stuff. But really, you get down to it's very simple. It's you count up the number of branching or looping constructs in the code and add one, and there's your cyclomatic complexity. The higher that number is, the harder it is to maintain the code, and when that number goes above 10 for any given unit, it starts to create maintainability issues, significant maintainability issues, defect clusters, and so forth. So, that's, I think, something you got to look at. Coupling. Obviously, if you got situations where there's a coupling between units, then that's technical debt. When you have units that are not cohesive, in other words, that they do more than one thing, that's also part of technical debt. Anything that poses a maintainability issue to the code. Static analysis tools can help measure technical debt. So things like uncommented code, confusing ways of naming variables and so forth. So there are a number of things that I think you need to look at here. But just in general, the more broken the code is, or the more unmaintainable the code is, the more technical debt you have. All right, so Brajesh asks, in a fix bugs first approach, how is regression handled? What happens to the defects introduced as a result of the defect fixes? That is a really interesting question, Brajesh. It kind of depends on what do we mean when we say fix bugs first, right? So the best practice would be that fix bugs first means exactly that before any work begins on the content of the subsequent sprint or iteration, that all the bugs are fixed, and the fixes are run, or regression tested using these automated unit tests and functional tests that I talked about in the presentation. And if those reveal any defects, those would also be fixed, and then you would actually start work on the features. Many teams aspire to have that level of diligence about this fix bugs first approach. Not many actually achieve it. I think it's certainly much more frequent that the bugs would be fixed, and people would move off to work on sprints. And if the regression testing revealed defects, then those would be dealt with during the sprint in some place. But at least if you had fixed bugs first, those defects would, if they were not fixed in that sprint, the sprint in which the defect was introduced, it would at least be fixed immediately at the beginning of the next sprint. Now, if you're getting a situation where there's sort of an infinite regress happening, which is every time we fix bugs, that results in the introduction of regression defects, then that gets back to the technical debt issue if you've got unmaintainable code. Lloyd asks a question here. Is your experience with Agile that the requirements are fairly complete and reviewed before development and testing are started? Some of the slides seem to imply it. My experience is the gradual transition to emergent requirements/design where they're not quite set until the end. In this environment, it's hard to plan or prepare tests, and with the design changing so frequently, it's risky to build a large test library. Yeah, so I want to be clear here about a couple things. One is that I was talking about Agile opportunities that arise when Agile is done well. So if Agile is being done in a very sloppy fashion, as the question that was raised by Andre earlier about, nothing's written down or nothing's very, very vague, it is, that obviously creates challenges, right? Now, what you're talking about too here, Lloyd, is the quote-unquote embrace change principle of Agile, which says that even if we're in the middle of the sprint, if there's a change in the definition of the requirements or the design, that should be okay. Yeah, I understand that as part of Agile principles, but in this case, I would refer you to my Agile testing challenges presentation, because that's one of the elements. What you've hit on here is one of the elements of Agile that is sort of essentially confounding to testing. That the ease of maintenance of any sort of automated tests or manual tests that are being built becomes critically important, because things are going to change, right? Things will change after they are quote unquote spec'd. I think it's important for people to understand that embrace change doesn't mean change is free. Change always has costs and risks as well as opportunities and benefits, and those are spread across the teams. And you really, in a mature agile implementation, it would not be possible to shut down debate about the pros and cons of a given change by saying, well, we're agile and we embrace change. That's something that would, to me, indicate a bad agile implementation. And again, I'd refer you to the Agile Testing Challenges presentation. Let's see. Mary asks, what specific skills should testers have and what priority should be attributed to those skills? So just generally, Mary, I would say I would want to see testers that had a knowledge of the programming language that was being used to develop the product, programming languages. I'd like to see them understand the various development environments and continuous integration environments and automated unit tests and static analysis and code coverage tools that are being used. I'd like them to be capable automators for the functional tests that are being created. I realize, Mary, that's a big step for some people in some organizations, so it might take a while to ramp up your team. But if you're bringing in new people into an agile testing world, I would say, man, you got to hold out for at least one and ideally two of those skill sets. Ideally, all three. But it's going to be hard to find somebody who's got all three. But yeah, definitely, you want to have people that are technical as testers and technical in the right way. I mean, you could, hiring a person who say was the best COBOL programmer ever is not the ideal situation when you're developing with Java. Not because of anything intrinsic in COBOL, but just because there's a learning curve associated with switching from a procedural language like COBOL to an object-oriented language, and it's a hump that somebody would need to get over. So Marcio asks, what metrics do you think are most important to collect in the Agile world? Now, I think this goes back to the three central testing metrics that one should have and be able to report, which is defect counts or bug counts, test case metrics, and coverage metrics. Now, I kind of bashed test case metrics earlier. I do think it's important for testers to be able to keep track of test case status from a execution point of view. What I bashed was using test case counts as a project reporting metric. I think coverage is much better. And when I say coverage here, I'm talking about, again, requirements, configurations, risks, so forth. So I think the same core metrics are still the key metrics to gather. By the way, I've got that book coming out on the ebook coming out here shortly on testing metrics, and that addresses metrics in a way that is suitable both for agile and sequential life cycles. Sharad asks, where are the slides? So go to rbcs-us.com, go to the resources tab. You'll see, then you float over the resources tab, the menu drops down, and it says library, and then you want to navigate through that to the basic library, go to the bottom of the page, and there you'll find it. If you go to the digital library in about a week, you'll be able to find a recorded version of this. Mohammed asks, hi Rex, how can we apply risk-based testing principles in Agile testing and at what stages? This is a good question. We have helped clients in a variety of settings, including sequential lifecycle models, agile lifecycle models, agile-like or more iterative type of lifecycle models. No lifecycle model apply risk-based testing. Now the trick is that in an agile world, everything is the formalization is minimized, right? And everything is made much more iterative than it otherwise would be. So what you typically want to do is at the beginning of a project, you want to do sort of a high-level overview risk analysis, identifying the general risk categories that you're worried about, some very general types of risk items. And then at the beginning of each sprint, your risk analysis is done as the user stories are written, and it basically becomes part of the whole user story development and estimation process. And so we've got a number of clients that are doing Agile and doing risk-based testing, and that seems to work pretty well. You got to remember that as things change, the risk analysis needs to be updated, and that then has to ripple through to the tests as well. So, again, it's an iterative lifecycle model. Everything iterates. Time for just a couple more questions here, given the time here. Charlita asks, will you offer any other Agile-related webinars in the near future? Well, again, the Agile Testing Challenges webinar is out there, posted on the digital library. A number of our, well, actually, most of our, if not all of our, webinars are life cycle neutral, so they would apply both in Agile and non-Agile situations. If enough people asked me to, I would actually do another live presentation of the Agile Testing Challenges webinar. What would constitute enough people? I guess if I got if we got 150 or more emails saying please re-present that, we'd do it. So I might redo that anyway in a couple years and just kind of revisit it. But if somebody was saying no, we really want it now, we could put that on the schedule. Another alternative is for this webinar or the Agile Testing Challenges webinar, or both. If you want those presented for your own company, send us an email and we can do a special presentation. We do charge for that, but certainly it's a lot cheaper than flying a consultant in and having him give a presentation on site. Here's an interesting comment from Carol. Yes, QAI accepted these webinars for my recertification last year. So that's interesting to know, Carol. Good information to share. Mary comments, so I can claim PMI PDUs. Yeah, oh, do you know, sorry. Do you know how do you know that I attended this webinar to send email so I can claim on PMI PDUs, Mary asked. The way that we know is that we have, that GoToWebinar knows that you're here, and it knows that you're paying attention. It sends out a confirmation email to those who did attend. So just the fact that you registered is not going to be enough. You have to actually be able to prove that you attended. That's why I said at the beginning that the PMI PDUs are only available for those who actually attend. Okay, we have more questions, but I just can't get to them. We're at a hard cutoff for our time. I thank everybody. If for those of you whose questions I couldn't get to today during this presentation, if you would like, there is another evening presentation of this webinar at 8:30 p.m. Central Time, and if you want to tune back in at, say, 9:15 or 9:25 or so, we'll probably be entering the question and answer session for that evening webinar session, and I'd be happy to get to your question there. Alternatively, if you want to copy your question into an email and send it to me, we can discuss it on the blog. I will have to point out that my workload has been such lately that blog postings are way backed up, but I would get to it eventually. I do thank all of you for your participation. To close this session, a little bit more about the resources. These free webinars run once a month, so watch our website, rbcs-us.com. You can sign up there. As I said, if you want a special webinar presentation of any topic related to software testing, including this topic, send an email, info@rbcs-us.com, or contact us via our website. You can sign up for our newsletter at rbcs-us.com. We just had one go out today, or yesterday, I think. By signing up, you get valuable discounts on our consulting and training services and a regular newsletter that includes a featured article on software testing and quality and news about what RBCS and its partners are doing lately. We are on Twitter, twitter.com/RBCS, and we're on Facebook. That's RBCS-INC. Check your email over the next couple days because you might be the lucky winner of a free e-learning course. As I said, check out the blog. Send me, that's rbcs-us.com/blog. Send me stuff you'd like to discuss, post comments on existing postings on the blog, and check out our digital library. You've got recordings of these webinars, podcasts, and videos. You can subscribe to the podcast on iTunes, the audio podcast versions. Enter RBCS podcast into the search string, assuming your iTunes ability to connect to the iTunes store isn't broken like it is in my PC over the last week. You can also subscribe to us on the RBCS channel on YouTube, and you can see the entire recorded webinar there. These free services are offered to the software testing community because at RBCS we are a not-just-for-profit company. That concludes the webinar. Thanks, everyone, for joining us. And again, for those of you whose questions I didn't get to, feel free to join the evening presentation or send them to me in email.